And we're going to do one more example. So let's say we're given a function f at x, or sorry, let's call this function a at x, okay, or a at t. Call a function a at t is equal to t cos 3t squared, okay. And what we're asked to find, so this question, what this question is essentially is, it's the equation of an acceleration, okay? And then what we're asked to do is we're asked to find the speed from that acceleration. So the question asks us, okay, find v at t. Find the equation of the speed. Sorry, find the average speed. Okay. So v at t, we know, is the integral of the acceleration. Okay, the integral of the acceleration dt. Okay. But not only that, we're asked to find the speed, the average speed from time 0 to time 1. Alright? So, in order to do that, we just take the integral of this acceleration function. So, in a similar manner, what we're going to do is we're going to define our placeholders. So, what we're going to do is, okay, we're going to write our placeholder box, use a different color, box is equal to whatever is in this bracket here, which is equal to 3t squared. And the derivative of that placeholder, using our power rule, so we bring the 2, multiply that by the 3, and that gives us 6, and then the exponent reduces to 1. So there we go, we have our first step done. And then what we're going to do is we're going to start working on our integrand. So we're asked to find it from the interval 0 to 1, so that means it's asking for a definite integral compared to the previous question where it was asking for an indefinite integral. And so we will write the integral from 0 to 1 of t cos 3t squared dt. Now when we put in our placeholder, this takes the form, like it takes this form here. So from 0 to 1, t times cos of our box times our d box by dt times dt. Okay, and as you can see here, you can visualize these t's canceling out here. And then what we can do from this point on is we can substitute our numbers in. So we would get the integral from 0 to 1 of t cos 3t squared, okay, that's this here, times d box by dt, which is this here, so times 6t. Okay, we're going to multiply this by 6t. Now, notice how we already have a t here. Okay, what we need to do now is just multiply it by something that will give us 6t. So since the t is already here, all we have to do is just add a 6, or sorry, multiply a 6. Okay, and that takes care of this dt. So now this isn't a good form for integrating. However, there's one small problem, and that is, since there's a 6 here, this 6 does not, the 6 makes this entire expression a different expression from this. So what we're going to do is we're going to fix that, and what we're going to do is we're going to make the 6 cancel out by multiplying this entire expression by 1 over 6. So now this entire expression is still the same as this. Okay, we're still asking for the same thing. But on top of that, this is in a form where we can actually integrate it. Okay, so if we scrolled up, you can see that it's in this form here. Okay, so now that it's in this form, we can go ahead and directly convert it to sine of our placeholder plus c. Okay, we can convert the entire integral from sine of our placeholder plus c. So what that will give us is, okay, 1 over 6 times sine, okay, of 3t squared, okay, from the interval of 0 to 1. And what that gives us is 1 over 6. So we're just going to substitute our numbers in. So sine 3 times 1 squared minus sine 3 times 0 squared. And close this bracket up. Close this bracket up as well. And then when you punch all those numbers into your calculator, you'll get a number that's approximately equal to 0.0235.